Hello, this is Thomas from Team 1002T presenting our submission for the VRC VR Challenge. My teammate Will and I originally attempted virtual skills by just using basic drive and turn commands, but that only got us so far. I wanted to implement some more advanced maths into the programming for more precise movements. I started by implementing a turn to coordinate function. I would need this function in order to drive to disks and aim at goals accurately. I first defined r sub x and r sub y as the GPS's x and y position. This is because I would be using the GPS's x and y position a lot in my code and wanted to condense the text. I created a function named turn to coord forward with the parameters g sub x and g sub y. These would be the goal coordinates. At the beginning of the turn to coord command, I calculate the inverse tangent of the gradient between the robot's position and the goal position. This outputs a number between negative 90 and 90 and acts as the reference angle. The field is mapped by the Cartesian plane, with coordinates from negative 1800 to positive 1800 measured in millimeters. Depending on where the robot was relative to the goal position, I would have to manipulate the reference angle differently. Using the graphing calculator Desmos, I created a representation of the field to help me visualize how I would get the robot to face the right way. Using the turn to heading command and setting the intake as the front of the robot, I worked out 0 degrees was at the positive end of the x-axis and rotated clockwise as the degrees were increased. I created a point that would act as the robot's heading. This would be useful in figuring out how the robot's heading relates to the inverse tangent. After playing with the positions of the robot and the goal, I noticed that the inverse tangent, arctangent, was the negative of the robot's heading if the robot was to the left of the goal. When the robot was to the right of the goal, it was facing the opposite way. Adding 180 degrees onto that would make it face the correct way. I implemented my findings into code and it worked great. I then created another function named turn to coord reverse, which had the headings swapped around, so now the end of the intake acted as the front. After creating a successful turn to coordinate function, all I needed to do now was to drive there. Using the distance formula, I calculated the distance from the robot to the goal position and subtracted 200 from that to account for the width of the discs. Although discs only have a radius of 70 millimeters, I had to remember that the position of the robot was based on where the GPS was located, at the back of the robot. Subtracting 200 millimeters from that actual distance worked well and always reached the discs. After the distance was calculated, the robot would turn to that coordinate and drive that distance. Using the turn to coordinate function, I created a function that would turn and shoot at the goals. I let the voltage be a parameter, as I would need to shoot the goals weaker as the goals got filled with discs. After setting the intake voltage, the robot would turn to coordinates 1350, 1350 for red, or negative 1350, negative 1350 for blue, and spin the intake for a given time. For more information about the code, check out the attached document. Participating in this virtual skills challenge has showed me that the maths I learned in school is not totally useless and that I can apply my knowledge into code.